In this example, we're going to be using a table to write a polynomial function that best fits the data. As we go through and do that, we need to identify, first of all, what type of polynomial function is going to fit the data the best. So we could be talking about maybe a quadratic or a cubic or a quartic. We don't know what degree power we're going to need in order to represent the information that is in this table well. So we're going to go through and look at finite differences using our y values to determine which of our different polynomials would be representative of this data the best. So as we go through, I'm going to take a look at each one of these y values, and I'm going to take one and subtract the one in front of it to find a difference. And 5,185 minus 4,267 is 918. And I'm going to do that with each one of these y values. I'm going to calculate all of the common differences and see what we get. So if you take each number, subtract the one in front of it, these are the differences that we get. This would be our first differences. What we're looking for is we're looking to see if those numbers are identical to each other or maybe nearly the same. And if you take a look, those are spread out quite a bit, all the way from like 900 something up to almost 5,000. So the first differences probably are not a very good way of representing the data. A first difference, the model that we would use, the type of polynomial that we would use, is a linear model. So these points are not in a straight line or nearly a straight line. It wouldn't be perfect likely anyway. So let's do the second differences and see if this is going to look like maybe a quadratic. So take each number, subtract the one in front. 981 minus 918 is 63. And if we go through and calculate all of the second differences, these are the numbers we get. And again, we're looking to see if those are the same or nearly the same. And those are pretty spread out again. So I'm going to assume that a quadratic is not a good way to represent this because the second differences, those numbers were not close to each other or the same. So we'll do our third differences and we'll see if maybe a cubic would be a good representation for these numbers. So take a number, subtract the one in front. Here are the numbers we get. And we take a look at those numbers, and those numbers are pretty close together. If you take a look, they're all in the 600s, so those are pretty close together. So a cubic might be a good way to represent the data. If you did go one more to see if maybe a quartic would be a good idea, we would end up with a common difference of 15 and negative 17, and those numbers are further apart than the numbers were in that red group, our third differences. So out of all of these differences that we've gone through and calculated, the numbers that are as close together as we can get are the ones that are written there in red. So I would not use a quartic. I wouldn't use that fourth degree. I wouldn't use the fourth differences. I would use the third. So this is our third differences. Which means a cubic function is what is going to represent this data the best. Our third differences were not the same identical numbers, but they were closer together than any other grouping. So we're going to use the third differences, which implies that we are going to be using a cubic model. Again, in our textbook, we have this table. And if your first differences are the same or close, we would have a linear model. Well, for us it was the third, so a cubic is what we would use to represent that information. In order for us to come up with the polynomial function for the data, what we would want to do is either calculate that by hand or rely on our calculator. The calculations to come up with a line of best fit or a regression line, which is basically a model, an equation that will go through, and if you plug in values, you end up coming up with the y values. An equation that goes through the points as best as possible is a pretty intensive calculation. So what we're going to do instead is we will rely on our calculator to go through and do that calculation. I'm going to go through and do that on the next video.